So this is what it is, guys. With this we are able to conclude, or we are able to we are able to say that we have done our insertion sort algorithm, right? Insertion sort algorithm, and that's what we have written. So uh, this simple is our insertion sort, guys. Maybe you might have seen this insertion sort, and it's expecting a different they say that what do you call, they do it in different complex manner, but actually speaking, this is not that complex. This is a simple and easy technique, and mm, and that's how this simple you can do it, guys. So let's move forward and try to learn our next sorting technique, which is selection sort. Okay, simple selection sort. I'll be explaining the simple selection sort for you. Selection sort is something like this, right? Insertion sort we have done. Insertion sort, like this is how our human brain thinks, and finally we were able to do somebody say something. What is that? How do we calculate the space complexity? Yeah, space complexity, as I told you, Priya, space complexity is nothing but space complexity is directly proportional. For example, let's say you have you have a method, right? Let's say m of, let's say array, or maybe it's an integer array. For example, you have written some code over here. So when you have an array, right? Let's say this array is of thousand thousand length, but in your code you have not used any extra space. I mean, you did not use any extra space. You have taken whatever is there inside, and then you did the same thing. You did not do any extra space. So that's why since you did not use any extra space, so this becomes order of 1. But let's say you are using an extra space, that becomes order of n or order of log n, etc, etc. I'll be teaching you when we move into, or when we jump into this merge sort, right? Merge sort, we use space. So how do we use space, or what is it doing, etc, etc. I'll be teaching you as we move forward in the session, correct? So now I'll straight away jump into one more sorting technique, which is selection sort, right? Let me move forward. So what is my selection sort? Selection sort is something like this. Where is my selection sort? Yeah. So selection sort is also a very easy to understand technique, guys. So it is nothing. There's nothing to break our head or something. And it's not complex. I'm telling you that straightforward. So what is my selection sort doing? Selection sort is doing nothing but what am I trying to do over here? So I have a number called 5, right? This 5, I'm I forget about all the other things. This 5, I should make sure that after I start with 5, I do not actually take care of this 5, but instead as I move forward, I try to find out the least element as possible, right? The least element as possible, and then I would what do you call, swap it accordingly. For example, in my total iteration, I came to know that -5 is the least element, right? -5 is the least element. So what I do, I take my first index and I will be swapping whatever is the number over here to the index of my 5. Same thing. So I came to know in my first iteration that the least element is what? -5, right? -5. And what I did is I tried to swap my 5 and -5, because 5 is nothing but the first element. So after this swapping operation, what happens is, until this part it is sorted, right? Because this 5 is at a correct position, right? What I want to do is, after this swapping, I can conclude that this -5 is at a correct position. So which means after this step, I can say it is partially sorted until which point? Until a point which is at index of 0, right? Now what I'll try to do is, again I'll start with my index which is next to 5, which is 1. I'll try to compare with every element in the array. I'll try to compare every element in the array. I came to know that 1 is the least element, right? Least element. Then I came to know that there's no point of swapping now. The reason is 1 is already in its correct position, right? 1 is already in its correct position. So now next again I'll take my next element. What is my next element? My next element is 12, right? My next element is 12. So my 12 I start comparing with every, or maybe after at 12 I try to find out the least possible element in this array. So I came to know 2 is something which is least. So what I'll do, I'll swap 2 and 12, right? After this step, what I can conclude is until this part, until this part, all my elements are sorted, right? All my elements are sorted. Now again I'll be comparing, or I'll be taking my next part of array. I'll be comparing, or maybe try to find out the least element out of it. So I came to know that 5 is my least element. I'll be putting it over here. So now again I move forward, right? So in here, what is my least element? 12 is my least element, right? So I'll swap 12 and 16. Again what happens? So my 12 comes here, 16 comes here, and again I'll start comparing. Now again I came to know that 12 is my least element. So what I wanted to tell over here is, in this small example, my steps are following. Take an element, or maybe I can say take number, right? Take number, and then you preserve its index, right? You preserve its index. You take that number, and whatever is the number which is right to it, right? Right to it. So whatever is the number which is right to you, you try to find out the minimum. Right? After you try to find out the minimum, you came to know that it also has an index, right? So this also has an index, so what you try to do is, after you came to know that this is the minimum element, you will be swapping these two elements, right? In this case, these two elements, right? These two elements. After you swap, so after you get this one, you swap. So after you swap, you came to know that it is sorted for the first number, right? For the first number. So these are the few important points over here in my selection sort. What do? I select a particular number. What is my selection over here? 5 is my selection. So what is the intuition of that selection? Selection is nothing but just came first in my index, right? So it just came. I've taken that, I've selected that element. Now I'll be taking the minimum of whatever is the element towards my right, and I'll be swapping that element with this element. That's it. Simple. Right? This is also simple technique, guys. There's nothing to break our head in it, because we can easily understand by seeing whatever is present in this small example, right? In this small example, there's nothing to even feel complex also, because we can easily understand. The only problem is, how do we write the code for this one, right? How do we write the code for this one? Yeah, how do we write the code for this one? Writing code for this one is also very simple, guys. So what is this here? Thumb rules. Let's say, maybe I'll try to say thumb rules of writing this code. Before we start writing pseudo code for this one, there are a few things that I need to make sure you understand. First thing is this also has two loops, right? Two loops. So what is my outer loop saying? Outer loop is just nothing but iterate over my total array. So what is my inner loop saying? Inner loop is nothing but it's finding the middle element. Find min, right? That's it. These are the two things that my two loops are doing, right? These are the two things that my two loops are doing. So without any delay, maybe I'll try to write or try to implement this code, right? This is my understanding, guys. This is my example. I came to know what is a selection sort. This is my example. These are my two loops. I came to know what my two loops are doing as well. So let's say I try to write code for this one. So what is that? Let's say simple. I'd like to write a for loop for int I is equal to 0, right? It started with 0, I less than length. So what is my length? Let's say arr dot length, right? Again I plus plus. This is my first for loop. This is for what? This is iterating. That's fine. And my inner loop is to find the minimum element, right? Minimum element, right? So instead of saying minimum element, I need to find the minimum index. So what I'll say is, I'll say int small index. So what am I inserting that to? What am I initializing that to? I'm initializing that to I. right? If you observe, I'm initializing that y. The reason, like maybe as we move forward, you can understand, right? I've taken a small index. Now again, so I need to write one more element, one more for loop for int j is equal to I plus 1, right? Because I'm trying to take the next element out of it. I'm starting with I plus 1, j is less than length, arr dot length, j plus plus. Okay, this is my second for loop. My second for loop, I know where should I start and until what point I have to actually, you know, iterate, right? Here is my condition. If so, what is that? I need to find the minimum element, right? So how do you find the minimum element? Is something like, it is also something like this we can do. If what I can say, data or maybe arr of small index is greater than arr of j. There's nothing here, guys. Same thing. We try to take this small index as I, which is 0, and j is nothing but I plus 1. We are trying to compare it. If the comparison is this one, which means if the small index one is having the greater, if same thing over here. So what we try to do is we are trying to compare 5. We started with, you know, 5 as our outer loop, and then our inner loop we are trying to find out 1 5 1 12 5, etc, etc. So after this we came to know what is the minimum element. How do we find the minimum element is also something that we have discussed over here. So here after this condition, simple thing that we need to do is this one. Small index is nothing but j, right? You came to know that is nothing but j. So after here you do nothing but you swap, and that's it. If we see, guys, in our pseudocode, we tried to do, or we tried to implement whatever we discussed over here, and nothing else we did, right? Nothing else we did. So first thing what we tried to do was, right, we came to know that we have to take a particular number, try to find out whatever is the smallest inside, you know, towards my right of it, and we try to do that in our for loop, right? We try to modify our small index as much as possible. Whenever this condition occurs, we are trying to modify our small index. And finally, whenever we came to a conclusion, after all iteration, we would be having our small index. Small index is nothing but here, after all our iteration, if we take that pseudocode, our small index would be pointing it to my 5. So what is my next step is I need to swap my -5 index and then 5 index. Then I need to swap between these two elements. Simple thing. So after that, we can achieve our selection sort as well, right? Maybe I'll show you the code directly. There's nothing to what do you call, think it's hard. What I did, I've taken the length of it, and I initialize the small index maybe to 0. So maybe to I've taken a variable called small index. Here I have a outer for loop. What is this outer for loop? This outer for loop is just to iterate over my every element in my array, and then I have a small index, right? After that, I have a for loop. What is my for loop saying? You try to check if this case occurs, right? If this case occurs, then you modify my small index accordingly. And after you're done with every comparison, you would be pointing the small index to the smallest possible element. So after you found out, then what you do is swap. That's it, nothing else, right? After you do, the thing that you do is to swap. All right, so let me try to test this, guys. Sort tester. So instead of saying insertion sort impl, I'll be saying selection sort impl. All right, selection sort impl. So this is my selection sort impl. All right, sorry, I'm copying this and I'm trying to test this one, and I try to do this one. I say I'm calling my selection sort method, right? When I say selection sort method, something like this, I say selection sort method. Maybe try to run this one. when I try to run this one, whatever we are trying to do is our input array is 642135, and we are able to sort it using my selection sort technique. And here I'm able to make sure that it is sorted in this particular way. It's so simple. This is how we can easily understand. We can easily understand that we can do it, right? These are not hard algorithmic techniques, guys. The only thing that we need to understand is what is an example for this, what my every loop is trying to do. Whenever we know what our every loop is trying to do, we can actually find. So yeah, okay, let me try to explain the code again. What it says, I have an input over here, right? I have an input over here. So what I try to do is I take my selection sort implementation. My outer for loop, what is my outer for loop is doing? My outer for loop is nothing but it's trying to move forward from my left side towards my right side, right? Here my inner for loop, as I told you in part of my explanation, I told you my doing nothing but is to find out the minimum element, right? Is to find out the minimum element. How do you find out the minimum element is? Minimum element is nothing but, for example, let's say our minimum element is like, let's say our array is something like this. Our array has 1, 2, 7, -3, and let's say 10. So how do we find the minimum element? For example, let's say we have a for loop for, right, arr dot length. So let's say I have for loop 0 to arr dot length, correct? So after, when I say 0 to arr dot length, so here what I will trying to do is, for example, let's say I say a number called small, right? I say int small, right? Here I say if small is equal to, for example, let's say I initialize that to a number. If small is less than arr dot length, in this case, what I'll say is small is equal to arr of I, something like this. What I wanted to do over here is I'll be comparing my small with every element in my array, and whichever is the smallest, I'll be initializing small to that particular element. And after I'm done with all my conditions or all my iterations over there in my for loop, I'll make sure that small is initialized to that particular element. And finally, I'm able to find my smallest in the whole array. The same is the intuition over here also, guys. What I try to do is I've taken an element or a number called small, right? So for that, I try to compare, I try to iterate over every element in my loop, all right, and try to find out what is the smallest, right? What is the smallest? I'm trying to find out the index out of it. Instead of finding or denoting the number, I'm trying to find out the index. The reason to find out the index is instead of finding the number, the reason to find the index is here as part of our example, we need to swap the index only, right? We need to swap the index only. The reason is we need to swap the index only, the 5 and -5. We came to know -5 is the number, but we have to remember what, not 5 -5. We have to remember the index of -5. So after we find out what is the index of -5, we do nothing but we do swapping. That's it, nothing else, right? We do swapping. Got it. Great. Super. So do not think that these techniques are harder, guys, and these are less than 4 or 5 lines of code. These are less than 4 or 5 lines of code, and just that you need to know about playing around with the for loops or while loop. That's it. Now let's move to the next programming or next loop technique or next sorting technique. So what is my next sorting technique? My next sorting technique is nothing but a bubble sort, right? Bubble sort. The name looks funny, even the code looks funny, but yeah, it's good way of learning these things. Okay, fine. Let's see what is a bubble, guys. What is a bubble? Bubble is nothing but, for example, let's say you see a bubble, like there are small kids which play with bubble. So what it does is it takes small droplets, and that's how it becomes a bigger bubble. So like it starts with what do you call it? It starts with small thing, and then it becomes bigger, something like this. It starts something like this, and then it becomes bigger. So what I want to say is, maybe I'm not able to draw the diagram properly. Let me try to do it. Starts with small, like that the bubble increases. Or maybe if we want to see that in a reverse direction, it starts with bigger, smaller, 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 smaller. So this is how a bubble is, guys. Okay, this is how a bubble is. So let's try to understand why this name came, or what is the actual significance of it, etc., etc. But before that, before moving to that, let's try to understand the space and time, the time and space complexity of the previous example that we have taken. So what is the time and space complexity? Here we already have, there are two for loops, right? We already know that there are two for loops. So what are those two for loops, right? It is, one is to iterate over, and then is to find the minimum. If we see in the code as well, this is what our inner, or selection sort says. It has two for loop, and there is an inner for loop. So which means when there are two inner for loops, we can easily conclude that it is nothing but having a time complexity of order of n square. That's it. So it is having a time complexity of order of n square. You can ask me, sir, you have taught a previous algorithm that is called as an insertion sort, that is also having order of n square time complexity. This is also having order of n square time complexity. So then what's the point of learning all these things? So I told you guys, there are different algorithms for different techniques or different uses, right? Why do we use an insertion sort? Why do we use a selection sort, etc., etc.? It has its own ways of doing things, right? We'll be discussing about what are the pros and cons of every sorting technique as we move forward. Okay, so let's say now our motto is to find out what is a bubble sort, right? What is a bubble sort, right? Okay, let me take one more slide. So what is a bubble sort? What is my bubble sort saying? Bubble sort is something that it starts from nowhere and then it increases. So bubble sort already has, or also has, a one more name. That name is nothing but a sinking sort case. Bubble sort. So this also has a name called sinking sort, or this has a name. This has one more name as comparison sort. Etc., etc., etc. Right? This is how these are the different names. This is a simple, these are the different names for the same algorithm. Now let's move forward. So what is my bubble sort saying? Bubble sort is saying nothing but it's a simple intuitive technique is. So let's say I'll try to take a small example and make you understand it even better, right? For example, let's say I have an input something like this, right? So I have an input which is 6, 4, 2, 1, 3, 5. These are my different numbers, right? These are my different numbers that are there, and I need to sort them as per my bubble sort. So what I'll try to do is I'll try to compare these two, right? I'll try to compare. I told you that this is a comparison sort, right? I'll try to compare these two, 6 and 4. I came to know that 4 should be before 6, right? I came to know that 4 should be before 6. So what I do is I'll say 4, 6, 2, 1, 3, 5. Right? Now what I try to do is I try to compare these two, right? So I came to know that 2 should be before 6, right? 2 should be before 6. So what I do is I again swap 4, 2, 6, 1, 3, 5. Now I'll be comparing these two, right? When I compare these two, I came to know that 1 should be before 6. 4, 2, 1, 6, 3, 5. Now again I'm comparing these two, right? 4, 2, 1, 3, 6, 5. Right? So again what I try to do is I try to compare these two. Okay, I try to compare these two. So what happens is 4, 2, 1, 3, 5, 6. Right? This is what, guys, this is called as my pass one. So as the name suggests, this compares with every possible or adjacent element. We take a particular element, we try to compare that with adjacent element, and if it is in a improper position, we just swap those two elements and nothing more than that. Right? Now we are done with our pass one. Right? Now let's move forward and try to go to our next step. So what it says, the input for this step would be something like this: 4, 2, 1, 3, 5, and 6. Okay, but here what I came to know is 6 is already in its correct position. Right? 6, it's done. Now what I'll try to do is I'll again try to do something like this. I compare 4 and 2. What I came to know that these two should be swapped. 3, 5, 6. Right? Now I'll compare this two. Right? I compare these two. 2, 2, 1, 4, 3, 5, 6. What I do is now I compare these two. Right? I say 2, 1, 3, 4, 5, 6. Correct? Now again what I try to do is I try to compare these two. I say 2, 1, 3. These are in its correct positions. So I say 4, 5, 6. I compare these two. I say 2, 1, 3, 4, 5, 6. Perfect. Now we are done. So this is nothing but this is called as pass 2. Right? This is what this is pass 2. Now let's go to our pass 3, guys. What is the input for our pass 3? The input for our pass 3 would be whatever is the output that we got in our pass 2. So let's say my input is something like this. My input is something like this. I say 2, 1, 3, 4, 5, 6. Right? I'm comparing these two. Right? I'm comparing these two. I came to know that these two should be swapped. Right? So I say 1, 2, 3, 4, 5, 6. Now I compare these two. I came to know that they are in correct positions. 1, 2, 3, 4, 5, 6. Right? So here if you observe, guys, here if you observe in this pass, these two are sorted, right? So on and so forth, right? Similarly, after this is called as pass 2, right? This is pass 3, right? This is pass 3. So after I'm given my pass 3, so what I came to know is let's say I move to my pass 4, right? Pass 4. What it says is whatever the output of my pass 3, it will be an input to my pass 4. It says 1, 2, 3, 4, 5, and 6. So after this, what I conclude is here all these elements, which means 4, 5, 6, these are in its correct positions and these are correctly sorted, right? Again, I try to compare these two. These are already in its correct positions. 1, 2, 3, 4, 5, 6. I compare these two, right? These are in correct positions. 1, 2, 3, 4, 5, 6, etc. So on and so forth. So this becomes my pass 4, 4, right? So here my pass 4 is this one, and let's say I'm trying to have pass 5, right? Pass 5 is nothing but it's something like this: 1, 2, 3, 4, 5, 6. Here if you observe, until this particular point it's already sorted, right? This also has, this is called as pass 5, right? Now I have my pass 6, right? Pass 6 is nothing but we already have 1, 2, 3, 4, 5, 6. But I came to know that all the elements after this are sorted and there is only one element which is already sorted, and came to know that it is already sorted. So this is what a bubble sort algorithm is there for me, guys. So bubble sort algorithm is nothing but it's already called, or it's also called as a, a comparison sort. So what do I compare that with? I compare that with my adjacent element, and if I came to know that it is having some problem or it is not in its correct position, what I do is I just swap that. That's it, nothing else. So this is my bubble sort algorithm, guys. This is my bubble sort algorithm. So are you able to understand what bubble sort algorithm is? This is very simple. We do that in pass by pass, hop by hop, we can say, right? uh, right, we came to know that our bubble sort is also a simple programming or algorithmic technique, and it's a very easy one. There's nothing fancy to learn about it. Now we need to write code for this one. Again we came to know that we should be iterating over every element, and if it is possible, or if we come to know that there is some problem, we need to swap. That's it. This is our understanding. So with this intuition, what we came to know is like there will be two for loops for sure, obviously. Let me try to write the code for you, and that code is also very simple, right? Let me try to write the code for you. This is the pseudo code. I'll be showing you the actual code as we move forward to run this one. So what is my pseudo code saying? So I have a outer for loop. What is my outer for loop saying? For what is my outer for loop saying? For okay, so maybe I'll try to write the for loop for this. I see somebody has messaged me. Okay, so I is equal to 1. So what we are trying to start it from, guys, we're starting it from 6, right, which is index of 0, right? I is equal to 0, right? I is equal to 0. I less than array dot length, I less than arr dot length, and I plus plus. So we have written a for loop for this, and after this for loop, we again have an inner for loop, right? What is that? For int j, where are we starting that? We are starting that, we are again starting that with 0 only, guys. If you see j is equal to 0, right? Maybe I'll tell you why we are trying to do this. J is equal to 0, j less than arr dot length minus I minus 1. I'll make you understand why we are doing this as part of here, j plus plus, right? This is also intuitive, guys. The reason why we are trying to write it is because of the previous example that we have taken. So here now we have an if condition. If what it says, arr of j is greater than arr of j plus 1. In this case, which means if you are comparing 6 and 4 over here, 6 and 4 over here, if 6 is greater than, or maybe here if you are comparing that the previous index with the index plus 1. So in this case, what you are trying to do is you are trying to swap something simple. So what we have taken an outer for loop. We are trying to iterate from 0 to until the length of this, right? Until the part of this, and then we are trying to have a one more for loop, and then we are having to try over this one, and we have here we are trying to swap. And what is our swap logic coming? Our swap logic is coming from arr j is greater than j plus 1. Simple, guys. Let me try to show the same code for you. Okay, so what is my same code doing? My code is doing something like this. What is that? It is having a bubble sort. Bubble sort is something like this. What is my bubble sort? Yeah, bubble sort implementation. So what is my bubble sort implementation saying? I have a for loop, I have an outer for loop, right? Outer for loop, and then I have an inner for loop. So what is my inner for loop trying to do? Inner for loop, what am I initializing that to, etc., etc. And then I have a condition, right? What is my condition? This is my condition. And then if this condition satisfies, then I'm trying to swap this one. I'll try to run this, and then straight away we'll jump into the next sorting technique, which is even more interesting. All right, so what is that? Where is my sort tester? Bubble sort implementation. I'll take my bubble sort implementation over here. I came to my sort tester, and I say bubble sort implementation. I'm calling what? I'm calling my bubble sort method, right? I'm calling my bubble sort method in my tester program. So when I try to call my bubble sort method in my tester program, I will try to run this one now, and here's it goes. So we have an unsorted input, and now we have a sorted input, which is 1 2 3 4 5 6. That's it. So even in here, guys, if you need to understand the time and space complexity for this one, so here also if you see, there are two for loops, right? There are two for loops, and obviously the time and space, the time complexity will become order of n square, right? Order of n square. And since we are not using any extra space, the space complexity will become order of 1. Simple, right? This is similar to all the previous techniques that we have already listened or maybe tried to learn till now. All right, now there is an intuitive question. So which one is better? Because all the three has order of n square time complexity. Why do we need to do all this, etc., etc.? So if we need to do all this, or if we need to learn all this, there are some things, some intuitive things that we need to find out. There is something called adaptive algorithm and online algorithm. So maybe I'll try to explain here. So what is an adaptive algorithm? So adaptive algorithm is nothing but, for example, let's say you have an input that is almost sorted, right? You have an input that is almost sorted, then it should behave in a better way, right? It should behave in a better way. That is called as an adaptive algorithm. If you take insertion sort, for example, if you take insertion sort, for example, maybe I'll try to show that you again. So what is my insertion sort saying? Insertion sort is saying nothing but, sort is saying nothing but, you're trying to swap the things, whenever there is no sort for that, whenever they are not in a correct position. So if you observe, if it is almost sorted, then the number of inner comparisons or inner swappings that you need to do are minimum. Or for example, let's say if your array is already sorted, then you come to know that you compare, and finally you come to know that there is no part of swapping, or there's nothing to do as part of your inner loop. So which means you're saying that it is already sorted, so I can do that in order of n only, right? Instead of doing that in order of n square. So that is called as an adaptive algorithm, guys. Adaptive algorithm is nothing but an algorithm that behaves better when you have almost sorted array. So the adaptive algorithm we can say is insertion sort. And the other sorts that we have learned, bubble sort, or then the other sort is selection sort. Even though your array is already swapped, or even though your array is already sorted, so there is no restriction. Bubble sort has to pass all the passes one by one. And even though it is already sorted, you will be doing order of n square time complexity, order of n square comparisons. So that's why it's not an adaptive. And the same thing goes for selection sort algorithms as well. So there is one more term that you need to understand. This is online, right? What is online sorting algorithms or online way of doing algorithms is, consider an input, and per iteration consider one input per iteration, which means you take one input per iteration and then produce a partial solution without even caring about what the next element is. You try to produce a partial solution without even caring about the next what is coming next, right? This you do only in insertion, guys. This you do only in insertion technique, and you're not doing that in other algorithmics or other sorting techniques. So that's why even for online is insertion sort. So there are two techniques that we try to learn, which is adaptive technique and online algorithmic technique. Adaptive is nothing but if it is already sorted, then you should make sure that it is doing that in a little bit less time, right? And online is nothing but, without caring about the next input, it just tries to find out the partial solution. That you are able to find it only in insertion sorting technique. And we can conclude the following two things, guys. What are the following two things that I need to conclude is, maybe I'll try to show that to you. So what is that adaptive and online algorithmic technique? So here it says insertion sort isn't an adaptive sort. Yes. Is it an online sort? Yes. Selection sort, it's not adaptive. Maybe you take an example which is already sorted and you will try to find out, you'll end up in order of n square. Same thing. Sorry, I think the third one should be a bubble sort. It's my mistake. Okay. Even for bubble sort, it's not an adaptive algorithm. It's not an online algorithm. This is some simple theory, guys. People generally ask, right? You have written an algorithm. Is it adaptive algorithm that you have written? Which means I give you an input that is already sorted. Will your algorithm behave in such a way that it performs better for an input which is already sorted? And you should be able to explain to the interviewer that you have written an algorithm which is adaptive, or maybe which is online, etc., right? This is one important thing that you need to actually understand this. Okay. So with this what we came to know is the order of time complexity. The time complexity that we have actually found out is order of n square. But even then we are able to conclude that it is being used differently for different things. And so you have a small data set, right? When you have a small data set, or maybe your input is very small, right, you tend to go to this insertion sort, selection sort, and bubble sort. And believe me, guys, the knowledge in these sorting techniques is important, right? You cannot expect, if an interviewer asks you to write code for insertion sort or bubble sort. Let's say interviewer asks you to write code for merge sort or quick sort. It has little bit more lines of code, right? It has little bit more lines of code in comparison. in comparison. But if he asks you to write code for this insertion sort, bubble sort, and quick sort, let's say he wants the what do you call, interview to be a little bit easier for you, or he wants you to select, or he wants to select you for some reason because he likes you, and he wants you to write an algorithm or write code for bubble sort, right? As I told you, this is two simple loops, right? This is two simple loops, nothing else other than that. Where is that? My bubble sort is nothing but just the two simple loops. And if you are not able to write this two simple loops, but you have already prepared for merge sort and quick sort, etc., etc., all these big things, then obviously you will be getting rejected. So that's why you should be having knowledge on this. Even though you are able to write the clean correct code for that to run at that particular point or not, that's not the important case. But the important case is you have to know about this bubble sort, insertion sort, selection sort. Because if interviewer thinks that he wants to make your interview easy without asking you the tough question, and he wants to select you, and if you don't know this, then believe me, you're gone, right? So that's why you need to learn all these things as well. Okay, so again, now let's try to find out our next sorting technique. Guys, I think we are little bit running short of our time as well, right? Running short of our time as well. But I'll make sure that I will be covering as much as possible. So our next algorithmic technique that we are trying to learn is merge sort, right? Merge sort. Or right, before moving to merge sort, I'd like to introduce you to one more sorting technique, guys. This I feel that there are two of my previous students or my colleagues, they started that, they asked this sorting algorithm in their interview. So that's why maybe I'll try to focus on this one. This is a simple one, but people tend to find that it is a little bit tough. But let's make it step by step, and let's understand it step by step, and after that we can jump straight away into merge sort, right? We can jump straight away into merge sort. That's it. Why I less than arr dot length minus I minus 1, etc., etc. Maybe what you can do is you can try to dry run your code, Wiki, right? Here, like if I try explaining that, I do not have time to explain for merge sort and right, my counting sort, right? This is simple one. This is just a simple loop. Maybe try to dry run your code, take an example. Why are we taking this one in here, etc., etc. So you can get it easily. It's not a big rocket science, right? Simple. And if you can even counter example, right, saying that why should we do this, why should we not do it in this way. So after that you come to know that we should do this, so that our algorithm works in this proper way, right? Now without concentrating on this, let's go to our next sorting technique, which is counting sort, right? Maybe I'll try to explain what is counting sort to you guys. Okay. Are you able to hear me now? Are you able to hear me now? Guys, is my voice audible? And are you able to see my eclipse? Right? Are you able to see my eclipse? Okay, fine. So now this is one more sorting technique, guys. This is a simple and easy one, but if we do not do it in a proper way, then it becomes harder for us to actually understand. So this is nothing but the next sorting technique that we are trying to learn about is called as counting sort, right? So what is my counting sort? Let me go back to my Microsoft whiteboard. Here I'm trying to write this, which is called as counting sort. So what is my counting sort, etc., etc.? Maybe we'll try to learn this. What we came to know is when we have an input of one particular sort, which is let's say big array, right? We are trying to find out that we can do it in order of n square when you take bubble sort or selection sort or insertion sort, right? But But consider an example where you already know the range of the numbers. For example, range of my numbers is like, it starts from, let's say, 0 to 9. Let's say, I have my numbers of 0 to 9. Or for example, let's say my array is something like this: 5, 9, 8, 7, 7, 7, right? 3, 8, 9, 7, 6, 6. Maybe I'll say 5, and then 2, and then 1, and then 0, and then 8, etc., etc. So it's moving on in this way, guys. It's moving on in this way. When you have something like this, an array, and it is coming in a particular range. Now I'm taking an example of 0 to 9, right? Of 0 to 9. So when you already have a range, then you should be able to make sure that you are somehow using this range to make sure your algorithm doesn't go to order of n square, but you can do it in order of n, right? So let's try to take the same example and make you understand, right? All concentration on here, guys, because this is little bit hard to understand, but it's not that hard, right? It's not that hard, but let me try to make it as clear as possible for you. Okay, let me try to make this as clear as possible for you. This is how maybe I'll clear everything now. Just a second. Okay, I'll clear everything, and let's make sure that we are doing it step by step. Maybe I'll input whatever is over here, whatever is over here. Are you able to hear me now? Okay, so I think you should be. So I'm inputting my just a second, guys. I would like to add an image, right? So what is that image saying? My image is saying something like this. So let's say I have taken an example of this sort, right? This is my example, right? This is my example. So let's say my example is something like this. I have this is my input array. Okay, this is my input array. I have the following examples. What it says: 9. Sorry, it says 9. Sorry, 9, 6, 3, 0, 1, 2, 5, 1, 2, 5, 2, 3, 5, 2, 3, 5, 8, 9, 9, 9. So what is it saying? It is having a range. And what is this range? Range is 0 to 9, right? Range is nothing but 0 to 9, right? Range is nothing but 0 to 9. And this is our input, guys. This is our input. Okay. So let me even try to find out or mark the indexes of this array. So index generally starts from 0, right? Right? Index starts from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. So this is my index also. Now what I have to do is I have to sort this, right? I have to sort this. So what should I do is I should make use of this range. I told you, right? I should make use of this range. So for this, as part of my step 1, right? I'll be doing multiple steps to do it in a better way. So what is my step 1? Step 1. So my step 1 is something that you have a count array. Count array. So what is this count array? Count array is nothing but you maintain the count of that many number of occurrences of a particular number. For example, let's say 9 is occurring 1, 2, 3, 4, 4 times, right? So in my count array, 9 should be having a count of 4, right? A count of 4, something like this, right? What I'd like to do is maybe I'll try to have one more empty array over here. So what I say is empty 10, right? This is just for my, easy understanding purpose. So what it says, so it has the following indices, right? It has the following indices. So what are my indices? Starts with 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, right? These are my indices. Simple, right? These are my indices. Now I need to maintain count, right? How many times 0 occurred, right? How many times 0 occurred? 0 occurred only once, right? Right? 0 occurred how many times? Only once. I'll have 1 over here, right? How many times 1 occurred? 1 came only once, right? So I'll have 1 over here. How many times 2 came in my input? How many times 2 came? Once, twice, 2 times, right? So I maintain this. I maintain this. How many times 3 came? 3 came 1, 2, 2 times, right? How many times 4 came? How many times 4 came? Is there any 4 in my input? There is no 4. So that's why my count of 4 will become 0. So how many times 5 came? How many times 5 came? So 5 came 2 times, right? Here is 1 and here is 1. 2 times. Now how many times 6 came? 6 came only once, and that is here, right? I'll say 1. How many times 7 came? 7, is there any 7 over here? In my input there is no 7, so I maintain that to be 0. So what about 8, right? 8 came only once if we observe, that is here. So I maintain this. So what is this? There is one more element which is called as 9, right? One more element which is called as 9. So how many times 9 came? 9 came 4 times, right? This is my first step, guys. This is very easy to understand, that we are able to do it. We are able to do it. We are able to make this count array. Now we have step 2. What is my step 2? Step 2 is to maintain cumulative array. No need to write all the big spelling, but yes, it's a cumulative array. Cumulative is like, I think maybe you guys have learned it in your 9th or 8th or I think 10th standard or something. Cumulative is nothing but whatever it came till now, I add everything and I maintain it at in a particular place, right? So there's nothing more to understand about it. But as we do the example, you'll know what a cumulative array is, right? Cumulative array also should be as long as my count array, right? As long as my count array. Maybe I'll try to increase its size. This is what my cumulative array says. Let's try to make it as big as possible, right? This is my cumulative array, guys. Cumulative array is nothing but we need to maintain the sum until a particular index, right? Sum until a particular index. So what do? I initialize that. Again, maybe I'll try to maintain the indices also, right? It is having index of 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So these are my corresponding indices, right? What I'll try to do is I'll try to copy whatever is there in my 0th index of my count array. So I'll put 1 over here, right? I'll put 1 over here, right? 1. So now to this one, what I try to do is for this, I'll be adding this and this. I'll be adding 1 and 1, it becomes 2 for me, right? It becomes 2 and 2. This one and this one I'll be adding, I'm putting 2 for me. And this 2 and this 2 I'll be adding, and I'll put 4 over here, right? 4 over here, 4 over here. And now this 4 I'll be adding with my next, which is 2. Again, I'll put 6 over here, right? 6 I'll be adding with the next element, which is called 0, right? I'll be adding 6 over here. 6 again I sum with 2, I'll be adding 8 over here. Correct? 8. Now 8 I'll be adding 1, so I'll put 9. 9 I'll be adding 0, I'll put 9. 9 I'll be adding 1, I'll put 10. 10 I'll be adding how much? 4. So it becomes how much? 14. Right? This is nothing but a cumulative array, guys. This is nothing but a cumulative array. So there's nothing to worry about it or nothing to do about it. What I did is I've taken a count array, and a cumulative array is nothing but I've initialized with whatever is the element. So I try to sum to my a particular index. When I try to find out, I try to sum my previous number with my next count, right? Same thing I try to do over here until this part, right? Should be clear, because there's nothing there's nothing to confuse over here. So this is my last step of my algorithm, guys. This is my last step of my algorithm. So what is my last step? Maybe I'll be inserting one more empty array, my output, and I can say that it is my result array, right? I can say that it is my result array. Result array also should be as long as my input array, right? So I can have it something like this, right? It should be as long as my input array. That's fine. I'm able to do it, right? So here, let's say I'm trying to take indices again, right? Let me try to make it as simple as possible, right? So here I'm trying to take indices, starts with 0, 1, 2, 3, so on and so forth. And here comes how much? 13, right? But for my understanding, guys, just to remove my confusion while writing my algorithm, what I want to do is I want to have an array of index 1. It starts with index 1, right? I want to have an array which starts with index 1. So that's why I'm trying to make this as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. Why am I doing it? Maybe you'll try to find it out. Why am I doing this? But there's nothing over here. To my index that is there already, I'm trying to add 1. That's it. I'm trying to add 1. We can make the modifications of whatever is required in part of our algorithm whenever required, right? Yeah, I'll be telling you why I'm trying to do it, just for us to make our understanding a little bit more easy. Okay, so what I did is I just added 1 to my index. That's it, nothing else I did. So now what I try to do is I try to do something like this. Now as part of my result array, I need to fill everything. Right? So what I'll try to do is I'll try to take element by element. First, I have my parent, right? This is my input array. Input array has a number called 9, right? Input array has a number called 9. And where should 9 be inserted in my result array? This is nothing but a result array. So what is that? It is result. So this is my result array. And what is this? This is my input array, right? So I'm trying to iterate over my input array. So I came to a number called 9. So where should 9 be inserted? So this count array is nothing but it's an intermediate array, guys. We are not trying to use this as part of our algorithm right now, but we are making use of this cumulative array. So how? I'll be telling you. We have this number called 9. Where should I insert 9? I should be inserting 9 at my particular index. This 9, where is this 9? 9 is over here, guys. So this 9 is having a number called 14, right? Number called 14. So what I do is I come to my result array, I come to my number called 14 and I put 9 over here, right? And I put 9 over here. So here what I did is I just have taken my first element in my input array, and I have put it over here. That's it, simple. So now what I did is as part of my my operation, I just made it, instead of 14 I made it as 13. I reduced it because I already used it. Okay, so here I made it as 13. Now I came to, and 9 is done. Now I came to 6. Where should 6 be inserted? 6 should be inserted at a position called 9, right? 6 should be inserted, and here I'm reducing it to 8. So I'm done with this one. Now I came to a number 3. Where should 3 be inserted? 3 should be inserted at a position called 2, right? 3 should be inserted, right? 3 should be inserted. Where is 3, guys? 3 is somewhere over here. Where is my 3? 3 should be inserted at a position called 6, right? 3 should be inserted at a position called 6. Where is my 6? So I should be inserting it over here, right? I'm done. So now what should I do is I should make it as 5 because I'm reducing it. Same thing that I did with my other elements as well. Okay, so now I'm done with my 3. Now there is 0, right? 0. So where should 0 be inserted? 0 should be inserted at a position called 1. So right, I'm inserting 0 here. I'm making that -1, putting that to be 1. So I'm done with my 0. So now I'll take 1. Where should 1 be inserted, guys? 1 should be inserted at a position called 2, right? I'll insert 1 over here and I'll make this one as decremented by 1. That's it. I'm done with my 1. Now there is 2. 2 should be inserted. Where should 2 be inserted? 2 should be inserted at a position called 4, right? I'm inserting 2 over here and I'm decrementing that with 3, right? I'm done. Now there is a number called 5, right? 5. Where should 5 be inserted, guys? Where should 5 be inserted, right? Where should 5 be inserted? 5 should be inserted at a position called 8, right? 5 should be inserted at a position called 8. So I came here, 5, 8. So I'm inserting it here and I'm decrementing that to be 7. That's it. I'm done with my 5. I came to 2, right? I came to 2. So where is 2? 2 should be inserted at 3, right? Right? 3. I'm inserting 2. I'm decrementing that and making it as 2. Right? Done. 3. Where is 3 inserted? 3 should be inserted. 3 should be inserted. 3 should be inserted at 5. Right? So 3. I'm trying to decrement that and make it as 4. Right? I'm done with my 3. So where is 5? 5 should be inserted at 7th position, right? So I'm putting 5. Right? I'm done. 8 should be inserted at position called 10, right? 8 should be inserted. 8 should be inserted at position called 10. So I'm putting it 8 over here and I'm making this as 9. Done with this one. 9. Where is 9 being inserted, guys? 9 should be inserted at position called 13. 13. And I'm making this to be 12th position. Done with this 9. Next 9, it should be inserted at position called 12. I'm done with this one, making it as 11. Done with this 9. And now my last 9 also I'm trying to insert and I'm making this as 10. And finally, with all this, I'm making sure that my array is sorted. By using this intermediate operations, right? By using this intermediate operation. And this is nothing but this is so intuitive, guys. This is nothing like after we try to take an example of something like this, we taken a full example of something like this, we were able to make sure that we are able to do it in a simple or simplistic way of doing things, right? So this is how we are able to do it. First we did by taking a count array, then we have taken a cumulative array, and then we have taken an output array, a result array, something like this, and tried to make some comparisons and tried to fill our result array. Finally made sure that all our result is sorted, right? All our result is sorted, right? All our result is sorted. So guys, just wanted to ask, like, are you able to follow? Are you able to follow this one? There's nothing hard in this one, right? Are you able to follow this one? This is a simple and easy technique. Perfect. Everyone is with me, guys. Everyone is with me. So there's nothing hard to learn this one. Only thing is we made sure that we have written a count array and we have taken this count array as a reference. Then we have made a cumulative array, and taking cumulative array as a reference, we try to iterate whatever is there in our input, and finally we try to fill everything into our output, and finally made sure that our output is sorted, and that's it, nothing else. So let's try to write code for this one. Okay, simple. Let's try to write code for this one. If we see, so there are various things that we did in this one, guys. First thing is, how do we try to make sure that there is that we are inserting into this count array? This is a simple for loop, right? This is a simple for loop, right? So this simple for loop, we are trying to iterate and we are trying to increase it. We are trying to increase it. So this count array is nothing but we came to a particular number called 9, right? 9. And what we did is we incremented this position called in the index of 9. We tried to increment it. Whenever we came to 6, we came to a position called 6 and we tried to increment it. So it's nothing but simple thing, guys. Simple for loop. What my simple for loop does is, for 0 to n, let's say, I think it's, maybe I will instead of doing it over here, I will try to do it towards my left. What it says is, for 0 to n, right? So 0 to n, what I did is I did something like this: count of ARR of I plus plus. something like this. It's so simple, guys. So what I did is I have taken a count array of size 9 and I came to know that ARR of I, what is my ARR of I? So in this case, ARR of I, it starts at 9, right? It starts at 9. So what I did is it starts at 9. So what I did is I tried to take 9 and in my ninth index, I try to increment its value because my initial value will be 0. So I try to increment its value. So to all my for loop, what I did is I've taken the index of my count array and tried to increment the value that is there inside the count array. So this is a simple thing. So now what is my second step is to find out a cumulative array case. So to find out a cumulative array, what I did is like instead of writing here, maybe I'll straight away show you the code so that it becomes even far more easy for you to understand. So what is this counting sort? Right? This is my counting sort, guys. So here filling my count array, what I did is I've taken a for loop, right, to my count array. So what is my count array? Count array is nothing but I've taken I've taken I've taken an array of this size, right? So finally, I try to fill my count array, right? I try to fill my count array. So count array filling is nothing but you're trying going to that particular index, and since the initial value or the default value for an array in Java is 0, you're trying to increment it. So what is filling the cumulative array? Cumulative array is nothing but it is also a simple thing. Guys, what we try to do is, guys, is my screen visible? Is my screen visible? Guys, is my screen visible? Is my voice clear? Is my screen visible? So, so as part of my cumulative array, so this is a logic for and there's a logic for cumulative array is also nothing but the first step that I told you is like in my first step of filling my cumulative array, I told you whatever is there in my count array, I try to put that into my cumulative array, and that's it. But after that, what I try to do is I try to iterate over my count array and try to fill my cumulative array. Just so this value I'm getting by taking the previous value of my cumulative array and the next value of my count array. Same thing, I try to put that into my code. Count array cumulative array of I is equal to cumulative array of I minus 1 plus count array of I. Same thing. That's it. So after that, what I try to do, I try to do something which is very simple, right? Finding where every element in input array should be placed, right? Input array should be placed. So something like this. So what is this one, guys? This one is nothing but the last step that we try to do. The last step that we try to do is try to find out. So here what I did is instead of taking the array to be starting with 0, I tried to take it as 1. But in my code, I'm correcting it, guys, right? In my code, I'm correcting it, right? In my code, I'm correcting it. Instead of taking it to be an index size of 0, right? It is taking an index size of 1. That's it. Okay, so here also it is taking the for loop, and finally we are trying to add the result array. And finally what we try to do is here in the cumulative array, here what we did is instead of making it 13 14, we made it 13. Instead we made it as 12. Instead we made it as 11. All these things we are trying to do in this line, and simple. So guys, if we understand the algorithm, it's not that hard, and if we understand the code, it's even very easy. So if you observe, there are 3 for loops, right? One for loop, and one for loop. And this for loop, the last for loop, is just to print my result. So which is just nothing, right? Which means there are 3 for loops which are not interrelated at all, right? Which are not interrelated at all. So that's why my order of my time complexity is not having any inner for loops. That's why the time complexity will become order of n, and it's not order of n square. That's it. Simple, guys. It's not order of n square, but we are able to achieve the sorting in order of n time complexity. Our quick sort and merge sort will give us the time complexity in order of n log n, guys. N log n, which is more than order of n. Which means this count sort is better. When is this counting sort better? It is better when we know the range, right? Here we came to know that the range is from 0 to 9. So that's why we are able to make sure that we are able to do it in a proper way. Let me try to run this program for you, right? So before sorting, this is my sorting. This is my input, and after sorting, I'm able to make sure that after sorting, it is printing in a proper way. So I've given you line by line, step by step example, guys. For every step that we have written, we wrote 2 lines of code, nothing more than that. For every step that we have written, we wrote 2 lines of code, and finally we try to make sure that we are printing it and make sure that it is properly working. That's it. Yes, counting sort has a time complexity of order of n. That's it. So line number 27, line number 27 is this one. So what is this line number 27? Line number 27 is nothing but it is actually arranging your input, right? Maybe I'll show you. So what is my line number 27 doing? I'll be going to my example. So what I did, I try to iterate over my range array, or maybe I try to iterate over my input array. So my first element is what? 9, right? Where should 9 be placed? 9 should be placed in an index of 14. How did we come to know that it should be placed at index number 14? We made use of cumulative array, right? We came to a number called 9. We found out what is the index, which is 14, and in 14 we try to insert. But here if you observe, my array is having the index which is starting with 0 and it's not starting with 1. Just for your understanding, I put that as 14, but actually it is not 14, but it is 13. So the same thing I did over here. I've taken a result array. This is my result array. So what did I do? I try to iterate over my input array. What is this ARR? ARR is nothing but my input array, right? I try to iterate my input array, and in my result array, so what did I do is there is this cumulative array, right? What is my cumulative array? Cumulative array of ARR of I. ARR of I is nothing but 9, right? 9. So I say cumulative array of 9. Cumulative array of 9 is nothing but 14. Cumulative array of 9 is nothing but 14. But I'm saying 14 minus 1. The reason why I'm saying 14 minus 1 is I need to insert at a position called 13. But it is in my result array, I denoted in the example as 14, but actually it is 13. So that's why I told you, just for our understanding, I made it as 14, just to not confuse you guys. So same thing that I did over here. And then I had this -1 so that I'm correcting that my logic into my array. And finally, I'm saying after I did this insertion, I'm doing nothing but I'm decrementing that value and nothing else, right? I'm decrementing that value and nothing else. That's it. There's nothing in this, right? Actually speaking, guys, we have done so much of explanation, but if you come to code, it's just one line, right? It's just one line. So this is what it is, guys. Data structures and algorithms, it's not about the big lines of number of lines of code. It's all about, right? It's all about your understanding. If you are able to understand the concept properly, selection sort is 3 lines of code, maybe 4 lines of code. Bubble sort is 4 lines of code. Insertion sort is 4 lines of code, right? And counting sort is, like, if I'm not wrong, 1, 2, 3, 4, 6 lines of code. That's it. This is the only logic that you have written. This is for printing, and this is for initialization. This is nothing, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 lines of code. So this is why all the big companies, they ask very small questions. They are less than 10 or maybe less than 20 lines of code. The only thing is you need to understand what is the logic behind it and make sure you're trying to put that into code so that the interviewer can actually judge your understanding, right? So here writing code is not important, guys, right? Understanding the concept is very important, because we tried a lot. We have taken an example, tried to put it here, there, here. We tried to play around with the indexes of array and nothing else, right? So this is what I wanted to explain. Previously, somebody has asked me, what about space complexity? Why is it not increasing? Here, the space complexity is there. The reason for having space complexity is we have an input array, but what we did is we have taken one more array, which is count array. We have taken one more array, which is cumulative array. We have taken one more array, which is result array. So for an input of size n, we are taken, we are taking some space, we are consuming space, some space which is 3 times or 3 arrays of size, right? Something like that we can say. So that's why what is the time complexity of this one becomes is the time complexity will become what is the time complexity, guys? Maybe first let's try to understand the space complexity. Space complexity is nothing but the space complexity is this. Space complexity is order of n plus r, right? What is this n? N is nothing but it is for result array. So r is nothing but it's for range, right? 0 to 9. So we have 0 to 9, the length 9 arrays of 2, which is count array, and then one more is cumulative array. So in this example also we have taken, so this is our input, this we have the size r is nothing but range, and then we have one more input which is size r is nothing but range, and then we have one more which is of size equal to the input. So that's why my space complexity will become order of n, right? Order of n plus order of r plus order of r. We cannot say 2r, right? We cannot say 2r because like we do not consider constants while explaining the time and space complexity. So this becomes order of n plus r, which is ideally be equal to, which is similar to order of n, right? Order of n. Why it is similar to order of n, etc., etc. That's a big story, guys. Maybe I require maybe 2 hours more to explain that. And now, what about space complexity, time complexity? Time complexity also, if we take, there are 3 for loops, right? There are 3 for loops. First for loop, it is iterating for how many times? It is iterating for range times. Here it is iterating for range times, and finally there is one more for loop which is iterating for n times, right? Which is again order of n plus r. Right? Again, the time complexity will become order of n plus r. The space complexity is order of n plus r, and time complexity is also n plus r. So this is all about counting sort. This problem was asked at least to 2 or 3 of my students who went for an interview in Amazon, and I think there is one more guy who went for an interview in Goldman Sachs, right? So this is not hard algorithm, guys. The only hard thing about this thing is like you need to take an example, and then you need to make sure that you are writing this algorithm, and finally you're playing around with all the for loops, right? Clear with everyone? Clear for everyone? Clear, guys? Even if you are not clear, I'll be giving you a notes for this one. Whoever needs the notes for this one, please ping. I think I've already shown the WhatsApp number. Whoever wants the notes for this one, you can ping. Yes, please mention that over here. Where is the WhatsApp number? You can take this WhatsApp number, guys. Whoever wants the notes, you can ping saying that I want notes for this class, and then we'd be ready to help you. So our final topic for today is merge sort, but I feel that we have exhausted so much, right? We have exhausted so much. Just wanted to ask you guys, shall we go to merge sort or shall we conclude the session? Shall we go to merge sort or shall we conclude the session? Because I promised until 1, now it crossed 1. Let's see, let's go with the majority. Please ping in the WhatsApp group